So, welcome to lecture number 11. And in this lecture, we will continue with the idea of structure and relation. So, in the last lecture, we were talking about this question, who am I? And I was trying to give an example of what relations mean. So, maybe we should continue from there. So, we ask this question, who am I? And for now, this I, we should take this, for this conversation, I means self, mind, thought, knowledge, experiences, memory. That is what means to me, the word I. And so it was necessary to make clear what this word means so we can be on the same page. So now we are mind, self, right? So does this I have self-existence? I mean, does it exist in isolation? That's what we're trying to say. I mean, do I have relation with this world, this physical universe? There is a star, here is earth, here is some moon, here is river, here is all my relatives and friends and everything. So do I exist in relation to them, or do I have some kind of separate relations? Or do I live in isolation? Well, in isolation I have no existence. I exist because there is this universe. If there would be no earth, where would I be? Right? So this is a legitimate question. So I am the object, and there are so many objects in this world. The idea is objects do not live in isolation. The mathematical object, for example, if you take, what does even 2 means? The number 2. Does this number 2 exist in itself? No. If we know piano axioms, what does it say? It defines number using a successor function, like successor of 1 is 2, successor of 0 is 1, successor of 2 is 3, and there is no number whose successor is 0. So the number is defined based upon the previous number, and the same goes with set theoric definition of number, the von Neumann construction. And we don't have to worry about these words. We will deal with this in the later coming videos. This is just foreshadowing, to make the point. So we define numbers, and each number is dependent on the previous numbers. They cannot exist in itself, right? I mean, what does it even mean when we say 2? I mean, doesn't 2 already contains the notion of 1? Even if we count, say 1, 2, 3, 4, we have the concept of before and after, right? Even if we change the order of the number, let's say I'm going to call 1, 5, 2, 7, and 3, 10. So I will count 5, 7, 10, 20, 3, 5 randomly. But that doesn't matter. That is a label. You can label anything. It's a symbol. Symbol has no meaning, right? Symbol has no intrinsic meaning. We impose meaning on top of it, right? So even if we name anything, whatever we want, there is an index attached to it, to this set of this number. So there is already an order into it. There is a structure into it. There is a relation between those numbers. That's why it works. That's why we can count, right? So number itself in the object, I don't think it has any meaning. The meaning only comes in the relation to something. Even take example of, there is a very famous example in the Buddhist philosophy. Take example of a car. What is a car? Well, does car have its self-existence? Well, I don't think so. And we don't think, because car is made up of various parts of the car. There is a wheel, there is a steering, there is the engine, there is the window glass, there is so many parts. right? There is nuts, bolts, right? And we put together all of them and we get a car. In a certain order we have to put it. So car is not some single object, it is a collection. And the same thing goes with the philosopher Nagarjuna, a Buddhist philosopher, in his book Mulla Madhyama Karika. In his book he writes, everything arises out of dependent phenomena, dependent origination. It means everything depends on another thing. Right? A plant to grow, it needs sunlight, it needs soil, it needs water, right? So the concept is nothing exists on its own. Everything needs a relation. All those objects exist in relation. It is dependent, right? We are in a interdependency relationship. And that same goes with mathematical object. What is a set even? Think for a moment. What is a set? Well, a set is a collection of objects. But then what are we going to do with this? Nothing. Why? We have to think it very carefully. A set is just collection of objects. Let's say a set of fruits. A set of natural number. And then throw away those order from the natural number. We don't want order in the natural number. We just arrange number. Let's arrange the number, right? Let's say we have number 5, 7, 10, 1, 2, 100, 7, 15, and so on. Just de-arrange the number of natural number and put it in a set. I mean, we know it is I know it is a natural number. So, because the in set order does not matter, that we know that. So we can again arrange it. But let's do for a moment, for the sake of example, there is no order in natural number. Let's suppose it. We impose the order on the natural number. Right? So we take those number and put it in the set. Now what are we going to do with this set? Well, we cannot do anything at all else. Why? Because this set has no structure imposed upon this. It is an isolated object. It has no meaning at all. In isolation, I mean. So what can we do? What are we gonna do there? We impose a different structure, and that structure belongs to. We know already what belongs to means. I belongs in this room. I do not belong outside this room. Belongs to means what is inside and what is not. So set theory is built out of this symbol belongs to. Now we take a set and this belongs to symbol and we put together and we form a structure. But this is still not a structure. It is a candidate of a structure. It will become a structure. And this is very important. A set and the relation that is belongs to this symbol put together, it is not yet a structure. It will become a structure only if and only if it satisfies axioms of set theory, ZFC, Zermelo-Fraenkel set theory axioms. If it does not satisfy, it is not a valid set. It is not a valid object. Okay. So it means objects do not live in isolation. We impose a structure on them. Given a group, take a set, put some operation into it. It is a candidate for a group. It has not become group yet because it had to satisfy some axioms. The concept is, what I am trying to say here, the concept is that there is object lives, mathematical object we have graph, we have topological space, we have knots, but they have no meaning in itself. It only becomes meaningful if we impose a structure on them, right? So, for example, let's take for a moment a graph. What is a graph? It looks like geometry, but it is not. We know that. So there is a point, and the point between there is a edges. Right? Now, this is a mathematical object, a graph. Now, what does it mean? Does it has any meaning in itself if we do not impose a structure on those vertices, on those whatever the pairing we have? If we do not impose any structure on them, then does meaning comes out of it? No. Meaning is in relation. It is in a structure, and we can see even through the philosophy of Ludwig Wittgenstein. He says in his book 2, which is philosophical, in book 1, not book 2, and the book is Logico Tractatus Philosophicus. He said, he starts with the very first statement that the world is facts. It means the world is not made up of objects, it is made up of facts. There are objects, electron, proton, neutrons, me, you, the self, the world, the consciousness, this universe, everything is there. So many objects. But the objects do not create meaning. They exist in a relation. Right? They are in a relationship. And we have different facts. The states of affair, about the states of affair. You see? So without relation, object is empty, I would say. I do not exist in this world without relation. That is a fact. Without this universe, I do not exist. Without this earth, I do not exist. Where am I? Nowhere. I am finished. I have no existence. So that's what I say. So the concept is, object has no inherent property. We impose on them. Right? We think natural number comes with order. I do not subscribe to this kind of thinking. We create order. There are different kind of order. Linear order, which is a natural number, has a real line. You take a real line and there is a number. First of all, I have to make one more clear things. Or maybe I can say it later. So, we have different kind of order. Linear order, cyclic order, partial order, right? We have different kind of order. So we can discover different order onto the object. Natural number, the order of natural number, which is the linear order or the order of real line, it has order. It comes, we think it is embedded in them. We define order. We can define any kind of order on it. Take a set of natural number, we define any kind of order, structure into it. But this kind of order, the order of counting, it seems embedded into the number itself, object. But I don't think so. Object has no meaning in itself. One is nothing. One means nothing at all. One only means anything if there is order in it. Maybe my screen is getting up. Okay, so order, what I was saying is that order does not come with number. Numbers have no order attached into it. They are just symbol. We impose orders on everything. When we define a sequence, for example, take an example from real analysis. What is a sequence? Well, we define it like this. We take a function. We take a function f, right? And then what we do, we take a function, this f, and this function will be from natural number to real number. So it will be from natural number to real number, right? And that is what we call sequence. Now imagine this for a moment. what kind of this natural number it is. In the definition of natural number, we have already imposed the order. Now forget that order. Now let's think this is a set of numbers. Well, then what we do, we take this set of natural number, which is what? N equal to 1, 2, 3, 4 and so on. So I think we should do it on the notebook to make everything clear, okay? So we have this function, and this function is from numbers to realign, and we know this is natural number, this set of natural number. Now what is set of natural number? We have numbers 1, 2, 3, 4 and so on. Now this is a set. Now what we do, since it is a set, order of number here does not matter. Then let's say we define a different kind of number. Not different kind of number, it is a same set. Just take the all element and put without order. Let's say I will say 100, 9, 8, 6, 1200, 4, 1, 3, 9, 7, 6, 5, 4 and so on. This set contains all the natural number, but without order. Now how do you define this sequence? It cannot be. Because then what is the position, the meaning of position? So we have to use notion of indexed set. You see, what I'm trying to say is, this is a set of natural number, right? So now we define a function. Let's say f of 100 is 150, f of 9 is 3, f of 8 is, let's say, 70 and so on. Now what is the first term here? What is the second term? What is the third term? How do you find Tn, the nth term of the sequence? We can find nth term of the sequence only because we have order in it. Let's say we have sequence 2, 4, 6, 8 and we attach this is the first term. This will be f of 1, this is second term, this is f of 2, this is third term, f of 3. But here, this is starting with f of 100, f of 9, f of 8, f of 6. So it is a problem for this. Why it is a problem? Because this is f of 100 equal to 150. Then how do we interpret it? Is it 100th term? Is it first term? What's happening here? And the sequence we can build, right? So what is happening here? This is the problem. And the problem only appears because we assume this set has no order, right? So it means to define a sequence, we don't think this natural number is just without any order. Well, a set has no order, but natural number comes with order, right? So it should be order. It is not just a set. We say this is natural number, comma, there is order on it, and then we get to real number. So this is what sequence is. This symbol means we are imposing a structure onto this natural number with order. Without this, I don't think this is any meaningful. There is no meaning in this natural number. I don't subscribe that 1, 2, 3, 4, it goes on. No, it does not go like that. There should be order in this. 1, 2, 3. To say this, after 1 it comes 2, then 3, then 4. There should be this order on this set. So then the number goes in this direction. If we only impose order onto it. So this kind of things is a structure. You see, take a number, take a set of number S. It can be anything, and then we impose order onto it. Then we get counting structure. We can get a counting, right? If this is set of number from 1 to infinity, and you impose order onto it, I don't like the word natural number. First of all, let's throw it away. Just say we have a set of number from 1 to infinity, and then we impose this order, and then we get natural number. Natural number is this one, right? A set, and then we define order on top of it, and then we get natural number. This is not only the set. With this set, it comes a structure, a set with some some operation or relation imposed upon this. So these things become a structure, right? So we are going to talk about this kind of thing from the next lecture, and we will expand this idea more formally and see what is happening. For now, I think we should stop here, and thank you for this.